our class on market structures, we'll look at the three main markets, starting with what is called the perfect competition, the monopoly, the monopolistic competition, and oligopoly. So these markets are distinguished by their different characteristics that you need to know. So when we're dealing with these ones, we summarize them in terms of the number of firms that are there in the market, the size, the nature of the product, and whether they are barriers to entry. So if we're dealing with the market structures, so perfect competition, there are many firms. So whenever we're dealing with perfect competition, what should come into your mind is a common market like Sokone market or Soweto market. So there are many firms there, and their average size is relatively small. Then when we are dealing with a perfect competitive market, their products are the same. We call this homogeneous. And they have barriers to entry. They have no barriers to entry. Anyone can enter and leave the market whenever they feel so. And also, there is no government intervention. So government has little control over the activities. Then the input and output decisions here, they have no restrictions. Then each firm is independent. They don't depend on each other. The profit-making possibility is low, and the price, when it's equal to the marginal cost, that's where profit is maximized. The graph is horizontal, and the pricing decisions are such that the marginal cost is equal to the marginal revenue, which is a price itself. So when you're dealing with a perfectly competitive market, these are the characteristics that you need to take note of. Now in a monopoly, we also have one major firm, very large in size. The goods in this market structure are unique, and there is high or heavy barriers to entry. They're significant. Government intervention is high because of the nature of the business being done here. There are heavy barriers to entry, and there are output restrictions. So what comes into your mind when you're dealing with the monopoly for Zambia? We're looking at ZESCO. Government will regulate how much must be produced for Zambia of a particular region in what quantities. In here, there are no competitors, so there's no interdependence. They make abnormal profits in the short run, and the relationship here is that the price is above the marginal cost, and the demand curve is downsloping. Profit is maximized when the marginal cost is equal to marginal revenue. So when you're dealing with oligopolistic market, we have two or more firms which merge to make or form a collision or a cartel. So the size of these firms is relatively high. When we are dealing with such firms, what should come into your mind are firms like IBM, firms that produce oil in the OPEC countries. They merge to form a collision. So the goods here are both identical and differentiated. There is a significant barriers to entry in this market structure, and there could be quite some government intervention in this market structure, and output is restricted. This market structure is strictly characterized by the interdependence that the firms have because of the price decisions. Their curve is kinked, so decisions at the kink will follow in a way such that when one of the firms that are in this oligopolistic market, they will agree to say, we'll sell at this price. If you decide to sell higher, they'll leave you. If you decide to sell lower, they'll go below you to put you off the market. So they make decisions interdependently, and profit making here is high. Our price curve is above the marginal cost curve, and the demand curve is downsloping but kinked. The elasticity here is both elastic and inelastic, and pricing decisions are strategic. So lastly, we are dealing with a monopolistic market. We are looking at markets where firms produce differentiated goods. So what should come into your mind when you're dealing with that? We're looking at differentiated restaurants, etc. So in this market structure, there are many firms, and there are SMEs that are predominant in this market structure. And their size is small to medium, and the goods here are heavily differentiated. The term we use is heterogeneous. Then we have barriers to entry, which are few. There is no government intervention. The output decisions here are that output is restricted, and each firm is independent of each other. The profit-making propensity is medium. The price is above the marginal cost, and the demand is downsloping. And our marginal cost is equal to the marginal revenue. Okay, so these are the characteristics of a perfectly competitive market. So we said the market has generally a large number of buyers and sellers, and the goods are identical. There's no need for advertising. So here, each buyer and seller act independently. Each buyer and seller here will act independently. And the elasticity of demand here is high. Why? Because our buyers know the prices of the particular goods and services, and as such, there is elastic demand. So in this sense, what we are talking about is if you want to buy tomato, which is identical, and it's supposed to be 5 kwacha, and somebody is selling for 6 kwacha, you're going to go into the inner parts of the market to buy a tomato which is worth 5 kwacha. So that is how elastic this kind of market is. So we also gave examples of vegetable farmers, dry cleaning companies, groceries. All these fall under a perfectly competitive market. So now I'll ask you to tell me the characteristics of a monopoly. Quickly tell me the characteristics of a monopoly. What are the characteristics of a monopoly? Number 1, Chippy, Elijah, Kosha, Munda, Nambela. In that order, give me the characteristics of a monopoly. Number 1.
Monopoly only one firm.
There's one major firm that is in control, correct? Chippy, number 2.
Yeah, the company sets the price itself and not the market.
The company is a price setter, whereas for perfectly competitive, they're price takers, correct? John Nkosha. Number 3 and 4, what are the characteristics of monopoly?
They are the only ones who sell the particular products.
And the product must be unique because they're the only ones who sell the particular product. So meaning the products must be unique. Yes. Next.
It has no cross substitutes. The products of monopoly.
Excellent. There are no cross substitutes. So meaning they have power, monopolistic power. Yes. So for a perfectly competitive market, we say that the graph should be horizontal like this. The price is the same as the demand. It's a marginal revenue. So what happens is the price is above the marginal cost. Then where the price and the marginal cost meet, this is where our profit is made. So you drop it down there where it touches the average total cost. This is called our economic profit. So this is how the curve looks like for a perfectly competitive market. So this is our economic profit. So what happens is in the long run, the average total cost curve will move upwards. So causing you to only make what are called economic profits. So this profit will be depleted. This point is called the shutdown point. So you discover that if you're dealing in a perfectly competitive market, firstly, people will want to flood themselves in the market by selling goods like handbags and perfumes and etc. so that they make a profit. So they'll get their largest chunk of the profit in the short run until it's depleted. At this point, your average total cost will now be above the price. So here, if you go above this point, you now start making economic losses. So you stop producing at this point, at point B. At point C, it's a shutdown. So don't go there. B is shut down. So this is basically how this market structure looks like. Then we want to look at a monopoly where we say there's only one major seller and these ones have barriers to entry. Examples is Zesco. So there are types of monopoly that we have. There's a natural monopoly, there's a geographic and a technological monopoly. As the terms speak, the natural comes about where the cost of production actually minimized by having a single firm producing it. For instance, a public utility company, Zesco, it's naturally a natural monopoly because of it being a public entity. Geographic is because of having certain geographic abilities, like the copper belt. The geographic monopoly that produces copper. Technological is based on the scientific research that has been done in a particular field. Government monopoly, owned by government, like a storage company. And the firm looks like this. Our demand, which is our price or our average revenue, is there. Half of it is got the marginal revenue. Then our marginal cost is U-shaped. It looks like this. The average is just down sloping there. So where profit is maximized at the point where marginal revenue is equal to marginal cost. So you go to where marginal cost and marginal revenue meet, you draw your curve upwards until it touches both the demand curve and our average total cost. So this is called an abnormal profit. So it makes abnormal profits in the short run. So this is how the curve looks like. So when we go to the characteristics, we say there are a large number of firms. There's only one firm in here. Then when we go to a monopolistic firm or market, we have a large number of firms that compete. Now these firms here produce differentiated goods, which we call heterogeneous. And these heterogeneous goods have freedom to enter and exit the market. And the product differentiation, what makes it different? We have aqua water, aqua pure, aqua savanna, all is water. We have Colgate, we have Aquafresh. They undergo what we call product differentiation. They also undergo what we call non-price competition, which goes through advertising, giveaways, and other promotions. They also maximize their profit when marginal cost is equal to marginal revenue. So this one slightly looks like the monopoly curve. So our marginal cost is here, then our average total cost is there, where it meets here, you draw your curve. So this one here, where it's minimum, that's where you draw this part. So this is called our profit, and this is a monopolistic. Monopolistic is different from monopoly. And finally, we go to our oligopoly. Oligopolistic market, where we have the following characteristics. We have a few large sellers that dominate the market here, e.g. McDonald's and Burger King. These ones will follow one market leader in this market who will give the pricing decision, will be a price maker. So they will make a collusion. A collusion is simply a form of agreement where they will set specific prices that will operate as a corporate or cooperative. For instance, OPEC, which is Organization of Petroleum Exporting Countries, where they will decide how much should be produced for Zambia in what quantities, what grade or quality. There's also what we call price discrimination, where they price different prices that are determined to different markets, but the same product. So the demand here is predominantly known to be kinked. So there are two firms here. There's a kink here. So if a firm decides to charge higher, they'll leave them. Charge below them, they'll go below him. So this is where the navigation of the pricing goes up. So these are the two demand. So we have our demand curve here, which is our average revenue. Then we have our marginal revenue here. Then we have the intersection of the average total cost and marginal cost. where the marginal revenue meets the marginal cost. We draw the line here, then it goes up there, where it touches the average total cost and the kink there. This is where the profit is determined. All right, so this is how the oligopoly looks like. So when we're dealing with computation of profit maximization, it goes back to calculus and optimization. So let's start with perfect competition. Question number 1. A perfect competition is considered by theorists and practitioners alike to be an identical market structure. Mention any 6 characteristics of perfect competition. Can you remember number 1? Characteristics of perfect competition, number 1. 6 of perfect competition.
No barriers to entry or exit, sir.
No barriers to entry or exit. Next. Quickly, guys. From explaining that.
The price is set by
the price is set by the market, and the price is equal to marginal revenue.
The price is set by the invisible hand, where the forces of demand and supply meet. Yes.
And there is no government intervention.
No government intervention. Karin?
And there are a number of firms, I mean.
There are plenty of firms available. Types of goods. What type of goods? The nature of goods in here?
Same.
homogeneous.
Yeah, homogeneous, mean they're identical. Excellent.
Homogeneous goods that are identical.
Excellent. The goods are identical. What can you tell me about mobility of the factors of production? There's free mobility.
Yeah, highly mobility. Yeah, they're highly mobile. You can remove or add to it.
Exactly. Okay. What can you tell me also about demand elasticity?
It's elastic.
It's elastic. Yeah, that's why we say it's a perfectly elastic. Perfect competition. It's perfectly elastic. All right. So we've been given the following. The total cost has been given by 100 plus 5q squared. Then we're also given our price per unit to be 100. We are asked to compute the profit maximizing output and the total profit. Okay, so now we go to a little bit of some navigation. To start with, in a perfectly competitive market, you need to know that total revenue, I think this is what we looked at in the previous class, is equal to price times quantity. Average revenue, who remembers? Average revenue is a price, which is the total revenue over quantity. Then the marginal revenue is what? Change in total revenue over change in what? Quantity. Total cost is equal to what? Total fixed cost plus what? Total variable cost. Profit, who remembers? Profit is equal to what?
Total revenue minus total cost.
Total revenue minus total cost. Okay. How about average fixed cost?
Total fixed cost divided by quantity.
How about average variable cost?
Total variable cost divided by the quantity.
About marginal cost?
Change in total cost over change in quantity.
So what happens when we equate the marginal revenue to 0?
This is our profit maximizing point.
Revenue maximizing point.
Revenue maximizing point.
What happens when marginal profit is equal to 0? So marginal revenue, when it's equated to 0, we are maximizing the total revenue. Marginal profit, when it's equal to 0, we are maximizing profit. Or the marginal revenue is equal to marginal cost, we are also maximizing profit. When marginal cost is 0, we are minimizing what? We're minimizing costs. So when you're looking at graphical representation, the total revenue looks like this. So if this is 12, the maximizing point of revenue will be half of this, which is what? 6. So this point here is called our maximizing output. Total revenue is maximized. Okay. And cost looks like this. So this is a point where costs are minimized. So to minimize costs, for instance, if you have a 3 there, you're going to find your minimum costs you're going to spend is that. So when you combine these two curves, you're going to have 5 important points. Is point A, point B, point C, point D, point E. Can somebody tell me what is point A and B? So point A and B is a point where total cost and total revenue meet. So we call that the break-even point. The break-even point. So break-even point is a point where our profit is 0. We're neither making a profit or a loss. Point A and point B, that is our break-even point. At point E, we're making a loss. So this is a point where what? Our total cost is more than our total revenue. Here, our total cost is equal to our total revenue. And in point F, that is where we maximize profit. So we are loss is a negative profit. Pi stands for profit. Okay, the positive profit is pi. So this is where our total revenue exceeds our total cost. At point C, this is a turning point. This is where total revenue is what? Maximized. At point D, the gap is longer here than it is from here to there. So that is called our profit maximizing point. That is the output that maximizes profit. So this is how you need to understand this. So before I do the computations, I'll start with a tabular form. Suppose our P, we are told, is 10. Then our total cost is 5. Plus 5 plus 9Q. 5 plus 9Q. So you are being asked number 1, or let me say it is 4 plus 8q. 4, 6 plus 8q. Let's spice it up. Suppose we're given this function 6, and here we have 8q. So you're being asked to fill in this. Okay. Our q, 1, 2, 3, 4, 5, 7, and 10. Our P, our total revenue, average revenue, our margin revenue, our total cost, our marginal cost, our profit. So we've been given our price as 10, so you can put 10, 10, 10 throughout. Then total revenue, who remembers how to find total revenue? Total revenue is what?
The quantity multiplied by price.
Good. So here we get a 10, here we get a 20, here we get a 30, 40, 50, 70, and what? 100. Then average revenue, who remembers how to find average revenue?
Total revenue divided by quantity.
Okay, total revenue divided by quantity. So we'll be dividing 10 divided by 1, 10. 20 divided by 2, 10. 30 divided by 3, 10. 40 divided by 4, 10. So in essence, our average revenue is a price. That's why we say average revenue is same as a price. Then who wants to give us the marginal revenue? How do you find the marginal revenue?
The change in total revenue divided by quantity, the change in quantity.
Good. Change in total revenue divided by change in quantity. The first one is a dash, so the change is simply the difference. From here to here, we have 10. From here to here, we have 1. So 10 divided by 1 is 10. The change from here is 10. The change from here is 1. So 1 into 10 is 10. Same here, we have 10. Same here, we have 10. Now here, 50 from 70 is 20. 5 here is what? 2. So 2 in there, getting 10. Here it's 30, there's 3, it's 10. So remember what we said, that the perfectly competitive market, the marginal revenue is the same as the price, it's the same as the, so it's a horizontal. So it's a perfectly competitive market. Price is the same as the average revenue. It's the same as our marginal revenue, which is our demand. Then the total cost, we've been given a function there, we just substitute. So when we put a 1 there, then we have 6 plus 8, which is 14. We put a 2 in this function, which is 16 plus 6. What do we have? 16 plus 6 is 22. Then when we put a 3, that is 24 plus 6. What do we have?
30.
Pardon?
30.
30. All right. So we discovered we're adding an 8 throughout. 8 throughout. Right? So when you put a 4 there, that is 32 plus 6 is what? 38. We just keep adding an 8. You discover that it's a scalar increase there. Okay. When you put a 5 there, that is 40 plus 6 is what? 56. All right. And put a 7 there. 7 there is what? 7 times 8. Huh?
56.
Plus 6.
56.
56.
Final answer is 56.
Yes.
Then here. We put a 10 there. 80 plus 6 is what?
86.
86. Then we look for the change here. First is the dash, change in total cost of what quantity. So from here to there.
On 7, I think it's supposed to be 62, not 56.
62.
Yeah. 56 is 8 by 7. Then you add the 6.
Okay. All right. So after getting this, how do we find the marginal cost? What do we get for the marginal cost?
So it's changing total changing quantity.
So what do we have here? 14. That is 8. All right. Then here. 30 divided by 1, that's 8. About here, 38, that is 8. Here, that's 8. About here, 62. 62 minus 46, what do we get? What is 62 minus 46?
16.
16 divided by 2 of 8. Then 86 minus 62.
24.
24 divided by 3.
8.
That's 8, correct.
8.
Then profit, how do you find profit?
Total revenue minus the cost.
Total revenue minus total cost. So our total revenue here, we subtract what? Total cost. So 10 minus 14.
-4.
Yes, here. Next.
Minus 2.
Pardon?
Minus 2.
Minus 2. Here.
Minus 2.
Are you sure?
Oh, no, 0, 0.
0.
Here. 2, 4,
4, 8,
8,
9.
pardon?
14.
Right from the king of
14. So identify the break-even point. How many units break even from this table? How many units will break even?
3.
3, correct. So here where our profit is 0, our 3 units will break even. All right. So now, sometimes the questions will now come in terms of functions. We're given our demand function, which is given by 100 minus 100 minus 2Q. Now total cost has been given by 5 plus 3Q. So number 1, find the total revenue. Find the marginal revenue. Find the maximum revenue. So how do we find the total revenue? Total revenue is given by price times quantity. So what is our price? 100 minus 2Q. Our quantity, we impute the Q there. So we're going to have 100 Q minus 2Q squared. But B, find the marginal revenue. Marginal revenue is the TR over the what? Over the Q. So we're differentiating this. What is 100Q when differentiated? 100. What is 2Q squared when differentiated? 4Q. Then to maximize revenue, how do you maximize total revenue? Marginal revenue must be equal to 0. So here we're going to say 100 minus 4Q. When the 4Q comes inside, we're going to say 100 will be divided by 4. So when we divide that one, our Q will therefore be equal to 25. Then the price, you put it in there, our price will be 100 minus 2Q, where there's Q, we'll put 25. So the price that maximizes revenue will be 100 minus 50, 50. So if you're going to illustrate that graphically, it will simply look like this. Here, the price that maximizes is 50. So meaning here it should be 100. The quantity we found as what? Price here was what? 50. Quantity was what? 25. So if that is 25, so here we're going to have 25 against what? 50, the price. Then this will be times 2. 25 times 2 is what? 50. So this is how we sketch our revenue function. So how many units to maximize revenue? 25. What is the price that will maximize? 50. But what is the actual total revenue? Total revenue is equal to price times what? Quantity. So if our price is 50 and our quantity is 25, so we're going to have what? 1, 2, 5, 0. So if this is our total revenue instead, here we're going to have 1, 2, 5, 0 as the total revenue. All right. Sometimes you'll be asked now, find what? The marginal cost, the profit, and the maximum profit. Okay, so our total cost was initially given by following function: 5 plus 3Q. 5 plus 3Q. So how do we find our marginal cost. The marginal cost is derivative of the total cost over the derivative of the quantity. I've already taught my calculus. If you are part of my students, at least you know what I'm talking about. So that is our marginal cost. And the profit, TR minus TC. Our TR we're just from calculating. Our TR was 100Q minus 2Q squared. 100Q minus 2Q squared. In the total cost, we have it there. Always remember to put it in brackets. So you put the like terms there. 100Q minus 2Q squared minus 5 minus 3Q. All right. So here we're going to have 100 Q minus 2Q squared. We arrange them in order. So what comes here? 3Q minus 2Q squared minus 5. So this will give us what? 97Q minus 2Q squared minus 5. So this is our profit function. Now, how do we maximize profit? We differentiate the profit. The profit over the Q is equal to our marginal profit. Then we equate it to 0. Anything marginal and you equate it to 0, it will be maximizing it. So 97Q becomes 97 minus 2Q squared becomes 4Q. What happens to the 5? It drops out. So when the 4 goes aside, it will be positive. So we divide by 4 on both sides. So what is 4 into 97? What is 4 into 97?
$24.25.
24.25.
25.
Correct. 24.25. Now the general term for optimizing may be either to minimize or to maximize. So if it's revenue, you know I'm maximizing. So if the question comes generally, optimize the following. Okay, they've given you TR is equal to 170Q minus 5Q squared. B, they've told you our marginal cost is equal to 20 minus 5Q. C, they've given you the marginal revenue is equal to 10 minus 2Q. Then marginal cost at the same time they've given you is 3Q. In part D, they've given you your marginal revenue only as 150 minus 10Q. So we are generally taught to optimize. So part A, since they've given us total revenue, obviously they want us to find the maximum output for the revenue. So we first need to find the marginal revenue here, which is the TR over the Q. So they've generally asked you to optimize. So when you differentiate that one, it's going to give you 170 minus 10Q. Then what do we do to maximize? To equate it to 0. When this one goes aside, it will be 170 is equal to what? 10Q. So when you divide both sides by 10, when you're optimizing here, it means our quantity is 17. What is 17? The number of units that will maximize your revenue. All right. And when we go to B, but B is asking us to optimize costs. So here, what are we doing? We're actually minimizing costs. Costs you minimize. How do we minimize costs? MC is equal to 0. So 0 is equal to 20 minus 5Q. And when this one goes aside, 5Q is equal to what? 20. And divide 5 on both sides, so meaning our Q is equal to 4. 4 is the number of units that does what? Minimizes your total cost. So part B, we're optimizing, part D, minimizing costs. In part C, we are given two things. Whenever you're given marginal cost and marginal revenue, you get these two, what are we doing? We are maximizing what? Profit. Profit has 2 points of maximizing. Number one, MR must go to MC. Number two, marginal profit must be equal to 0. Okay, so suppose we're given marginal profit there, 120 minus 6Q. So here, our part C, we're just equating marginal revenue, which is 10 minus 2Q is equal to 3Q. And this one goes aside, it will add. So we're going to have 2Q plus 3Q. So meaning our 10 is equal to 5Q. So when divide both sides by 5, our Q therefore will be equal to 2. So what is our 2? These are the units that will maximize what? The profit. And when we go to D, it is direct. When you equate the marginal revenue to 0, what are we doing? We are maximizing the revenue. So 150 minus what? Minus 10Q. When this one goes aside, 10Q is equal to 150. Now divide both sides by 10, our Q is equal to 15. What does 15 mean? The units that will maximize what? Maximize your revenue. Then when we go to our E, E there has given us what? The marginal profit. So marginal profit, when we equate it to 0, what is happening? Marginal profit, when it's equated to 0, what is happening? We are maximizing our profit. So when we equate it to 0 there, we have 120 minus 6Q. When this one goes aside, 6Q is equal to 120. And divide by 6 both sides, Q is equal to what? 20. So whenever you hear the word, find the units that will maximize your output. So let me go to your pamphlet and summarize your module into this question and answer. Those that want to get it. So I've done all the examples and the exercises. I've put them in this question bank. So we're given the total cost here. All right. So can somebody help me? Don't embarrass me. I've explained everything. So we're given the total cost here. We're also given the price here. How do we compute the profit maximizing output? Okay, what we have? Total cost is equal to what? 100 plus 5Q squared. And our price is equal to what? 100. So how do we find the profit maximizing output? We have two ways. We said to maximize profit, marginal cost must be equal to what? Must be equal to what? Marginal revenue.
Marginal revenue.
Correct. So when you differentiate this one, our marginal cost will be what? The TR over DQ. So we're going to have what? 10Q. Now this is a perfectly competitive market. You know that the price is the same as what? Marginal revenue. It's the same, which is the same 100. If you want, you can still evaluate it, no problem. Total revenue is what? Price times quantity. So here our price is 100. 100 times Q, 100Q. That is our total revenue. So when you differentiate it, our marginal revenue will be the TR over DQ. It goes back to 100. It's the same principle. This is a perfectly competitive market. So we're going to equate our marginal cost is what? 10Q. Our marginal revenue is 100. So when you divide both sides by 10, our quantity is the output, like I have mentioned. Quantity stands for output. So how many units will maximize profit? So to maximize profit, we're going to have 10 units. Then they are asking us to calculate our total what? Profit for the firm. So we know that profit is got what? Total revenue minus total cost. Our total revenue, we calculated it briefly here. It is 100 what? 100Q. So put 100. Never forget to put brackets because this is where the examiner will catch most of you. This is a function. So our function for total cost is 100 minus 10Q squared. Right? Is it 100 or 10? So 100 plus 5Q squared. So this negative here, using the operations of maths, will negate everything in there. If there's a negative, it will become a positive. If there was a positive, it will become negative. So what is the maximum profit? So here, there are no like terms, but we calculated our Q to be what? 10. So when you put it in there, we're going to have 100, where there's Q, put a 10. Right? Minus 100, where there's a Q, you put 10 squared. So here we're going to have 1000 minus 100 minus what? 500. So what are we going to get? 100 minus 1000 minus 600, it will be 400. So the profit that maximizes the actual our profit is 400 kwacha in terms of the figures. All right. So I transitioned from explaining the market structures, the characteristics, now going to calculations using the tabular method, as well as our showing the tabular methods, as well as our what? Our computations. So I will end here for now, unless there are any burning questions.